Hello, everyone. Thanks for coming today. I am Ricardo. This talk was done in collaboration with Guillaume Lemaitre, who's great, and unfortunately could not join us today. Guillaume is there for help during the Q&A session. But since I'm the one who's starting, I have my own ego slide. So who am I? I'm a research engineer at INRIA. It's a French state research institution. And I'm part of the P16 project. If you don't know it, it's a project whose intent is to develop promising scientific open source libraries and by assigning good experienced engineers to them. So I am the lead developer of Skrub. About myself, I'm Italian, but unlike most Italians, I don't drink wine or coffee, and I like pizza with fries, and please don't leave the room because of this. Also, I spent a lot of years in France, in the south of France, actually, but I moved to Paris because it was too sunny and I don't like the sea. So that's enough for me. If we can talk about Scrub with a typical calling phrase, boost your productivity with Scrub, but that's actually the intent. And most of the things that you will see about Scrub today, the intent is to simplify your life when you're working to prepare data frames for machine learning fast. So the idea is that you will see a lot of things that you probably have to do very often during your workday, and maybe Scrub can help with that. So I'm going to start with a small teaser of something that you will see later, and it's this complicated looking graph, which has a bunch of things. You see this table representation, you see this table vectorizer, all this that you will find out in a moment. And since it's a teaser, I'm not going to explain what that was about. You will see it later. And then there is a very scary looking plot, which is not that scary because you can actually interact with it. And you can actually see that if you can filter all of these red lines to see only the ones that have the best score. This is a parallel coordinate plot that will also come into play later. Yes, it's a teaser for a reason. Compatibility, Scrub, everything you see today, it works both for Pandas and polars, and it's not actually using arrows, surprisingly. And another thing is that all transformers implemented in Scrub are fully compatible with scikit-learn, so you can put them into a scikit-learn pipeline and they will work. They should work fine. What do I mean by pipeline? Just so we are on the same page. We gather some data, we explore the data to find what are the unique values, what are the missing values, what are the data types, and so on. We will process the data because data is never clean. And then we do some feature engineering to get some features out of it. You can use scikit-learn, Pandas, Polar, so whatever library of your preference. And then you say, we build a scikit-learn pipeline, hopefully we profit at the end. However, if you're like me, you see a table in the distance and you think, oh crap, here we go again, because you remember all the time you've wasted trying to clean it. And I personally have, yes, I have some PTSD from that. Yeah. So this is, I'm not going to go through this very long script. It's just to show you what it takes to plot bar plots to show the distribution of two columns in a data frame. It kind of looks a bit like that. And yeah, okay, it looks kind of good, but you have to write a bunch of lines of code. You need to remember the syntax and so on. What Skrub does for you is provide you the table report. The table report is this fancy looking preview of your table, which contains all the columns in the table, as well as the first and the bottom lines that just give you an idea of what's inside. You can filter the columns according to some pre-compiled filters. You can check a high-level overview of what's inside the table, the data types, what are the null values, where are the null values, how many unique values you have. Additionally, you have some additional stats for numerical features, like mean, median, and stuff. You can have a distributions tab, which is just going to show you the same plots that I've shown in the previous slide, except they've been pre-computed for you. You did not have to write any code. And this is very useful to get a grasp of what's inside the table. Additionally, you can see that some columns maybe have a very imbalanced distribution, and you will have to deal with those. The final tab is the associations tab, which is showing you which columns are strongly correlated with each other. In this case, there are two columns that are perfectly correlated with each other, so you might want to drop one of them, because if you're working with linear models, they don't like this kind of data. One important thing to say about the table report is that it is fully offline. It is just an HTML file with some JavaScript for interactivity. So you can save it as an HTML file, and you can open it in any web browser without having to spin up a Jupyter Notebook or some kind of Python core. There are a couple of additional examples in the link that I'm putting here in the description. And you can find at the bottom, there is the footer where you will find more examples about Skrub, as well as the slides for this presentation. And the slides are also in the schedule. Now that we can explore the data, we can also do data cleaning using Pandas and polars. And here I have just an example of a small dataset that contains some uninformative features. There is a feature that is all constant. There are a couple of features that are all empty, so we don't really have any information about that. There is a date feature that is written in a weird format that is not really parse the date, as you can see from the Pandas representation. So if you want to deal with all of this, you have to write a bunch of code in both Pandas and polars, which is kind of complicated, and you can see here what it kind of looks like. You don't really need to understand all of the syntax just to show that it is very complex. The alternative is to use the Skrub cleaner, which is doing all of that for you. So the Skrub cleaner is going to drop the empty columns. It is, in this case, dropping the constant column. And since I've passed the format for date time, it is also going to parse the date as an actual date time. And the cleaner in general is fairly conservative. It will not drop columns unless you ask it to, except for the completely empty columns. Speaking of datetimes, if you want to code datetime features using Pandas or polars, you are going to have a datetime column that you need to break and unpack into its all components. So the year, the month, the day, etc. And to do so, you have to write it on every single line separately, like in the example that I have here. This is kind of wordy and complicated. And if you want to add periodic features, you still have to add them manually by yourself. What you can do is you can use the Skrub datetime encoder, which is doing exactly the same for you. So you pass it a datetime column, and it will give you a data frame that contains all the parts of the datetime. Additionally, you can also add periodic features if you want. So this is a very easy way to just encode datetime features. Periodic features look kind of like this. These are splice. They are used to add additional patterns to your features, so that the linear model can actually learn something more from your data than it would be able otherwise. So if you're dealing with numerical features, you might be in this kind of scenario where you have most of your data in the range -2 + 2, and some of the outliers, which are all the spikes, which are in a much larger range, like in this case, -40 + 40. If you're trying to train a machine learning model with these features, you need to do some scaling. The problem is that if you use traditional scalars like standard scalars or robust scalars, you're going to encounter some issues. The standard scalar, which is the red line here, shows that the inliers are a horizontal line, which is not very informative, while the robust scalar, which is the green line, instead is showing you that it is working well for the inliers. However, for the outliers, it is even more off the scales. So Skrub solves this by you providing the squashing scalar, which is a transformer that clips all the outliers to a finite range, so that you know that any kind of outliers is going to be at most as large as the outer range that you define. And this is particularly useful for linear models and for neural networks, because you know that the range is not going to be off. This is the other side of Skrub. If one side is good engineering to save you some time, the other is good statistical thinking in using good defaults and good methods from the literature like this one. We've talked about datetime and numerical. Now it's time for the categorical features. So categorical features, by this I mean strings or text. And categorical features have a cardinality, which is the number of unique values that you have. If you have a low cardinality, like the size of a t-shirt, like S, M, L, and so on, you can use a one-hot encoder. The problem is that if you have a lot of unique values, this does not really work well, especially with data frames, because data frames are dense. So if you have a large number of unique values, you should rather use something like a different encoder that keeps the number of components fixed. And Skrub has a few of them. The default one is the string encoder, which is a TF-IDF followed by SVD. So it's latent semantic analysis, if you're familiar with that, which works pretty well in most cases. However, there is also the text encoder, which is useful if you're working with text, like reviews, descriptions, tweets, and so on, because you can use that to kind of wrap a pre-trained language model from the Hugging Face hub and use that to generate your features. Now that we can encode all the features, we kind of provide a second major time saver, which is a table vectorizer. So the table vectorizer is a tool that kind of takes a data frame as input, And it gives you as output the encoded version of the data frame, meaning it applies all the encoders that I've explained up to this point, and it gives you immediately a feature matrix as a data frame. Specifically, it first applies the cleaner to all the columns, and then it splits the columns by data type and by the number of unique values. So each column has its own category, and then it encodes each column separately. So here it's going to be low cardinality will get one-hot encoding, datetimes will get a datetime encoder, high cardinality a string encoder, and then you have a pass-through for number by default. You can also customize all the categories. So if you want to use a text encoder for high cardinality, you can do that. And now for the third time saver, you have the predictive pipeline. So just here, for the sake of the example, let's say I want to do a rage model. But then you have to add all of this to make it actually work in practice. And it's still not really that good because I just left the one-hot encoder there. The alternative is using the tabular pipeline provided by Skrub. And what it does is it takes an estimator or the string regression or classification, and it will give you a full pipeline, a full scikit-learn pipeline that has a table vectorizer as the first step. And then in this case, going to add the simple imputer and a standard scaler because we're working with Rage. And I want to summarize the first part with this. So the top is plain scikit-learn, which gets kind of complicated, as you can see. And the bottom one is scikit-learn plus a bit of Skrub. And you see that it's so much easier to digest like that. So now we have a pipeline because we have the data. We can explore the data with a tabular report. We can preprocess the data with a cleaner. We can do feature engineering with all the encoders or just the table vectorizer do its thing. Then we can build a scikit-learn pipeline, and this time we actually profit. However, what if this is not enough? Second part of the presentation. What if your data is spread over multiple tables and you want to avoid data leakage, especially when you are doing joins across multiple tables? What if you want to tune more than just the hyperparameters of your model? Like you're not sure if a choice that you've made in your processing is useful or not, or maybe you want to tune how you're doing a specific operation. How do you guarantee that after you've chosen all the parameters, you replay exactly the same operations on new data? When a normal pipeline is not enough, the Skrub DataOps come to the rescue. So the DataOps extend the scikit-learn machinery to multi-table operations and take care of data leakage for you. They track all operations with a computational graph, what we call a DataOps plan, which you have already seen. They are transparent and give direct access to the underlying object, meaning that if you are using a Pandas data frame, you actually have access to all the functions that you have in Pandas, and they're just going to be passed to the data frame, and they will be tracked by the DataOps. They'll let you tune any operation in the DataOps plan, including these Pandas operations, and they guarantee that all operations are reproducible. But finally, they can be persisted and shared easily, as I will show. DataOps work by wrapping around user operations, where a user operation is any data frame operation, as I mentioned, scikit-learn estimators, or custom user code. So say that you have to fetch data from a remote bucket, and you only have a URL for that. What you can do is you can write a function that takes data from that bucket, it turns it into a data frame, you put this into your DataOps plan, and it's going to just replay that operation on new data. So the idea is that DataOps record the user operations so that I can then replay them in the same order with the same arguments on unseen data. To start with the DataOps, it's simple. You just need an entry point to the DataOps plan, which are the variables. In this case, it's baskets and products. And then what you want to do normally at the very start is to mark some of those variables as X and Y. So you need one X and one Y, of course. The idea is that by telling Skrub, this is X and this is Y, Skrub, whenever it has to do a split for validation, for cross-validation, for any kind of operation, every time there is something that should be done only on the training split, it will be done only on the samples that have been marked as training. And this is how Skrub is avoiding data leakage, because it's kind of keeping track of what are the training samples and what are the testing samples. Now that we have the variables, we can apply a vectorizer. So I'm applying a vectorizer to products, and the table vectorizer is my vectorizer. And I'm not applying it to all the columns, only to a subset of them. And the selectors are something that is very powerful in Skrub. They let you select columns according to a bunch of also possibly custom filters, but I could not fit it in the time, unfortunately. Then I can use the data frame operations from before and get a feature matrix that I can use. And then I can apply a extracted tree classifier for this example to get the predictions. This is actually just the final step of the data ops. These are not going to be the actual predictions of the classifier. You need to actually train this thing. Now we can inspect the data ops plan, and now you actually know what the table vectorizer is. You know what this is. This is a table report, and this is what the result of applying a table vectorizer to the table products. So you have a lot of information in the report. And the idea is that you also have where you define a specific line of code. So you know where you're doing, what the line of code was like. And what you also have is that this report is fully offline. Once again, you don't need a Jupyter Notebook to access it. It's HTML. And one thing that you can do is once you save the learner, I will explain what it is in a moment, which is like once you save the data ops plan, you can come back to this in a few months' time, load it back, and you get the same report to say, okay, this is what this thing is actually doing. So it's all, and you can mark nodes. So it's very easy, helps with maintainability. So the learner is the idea of, hey, I want to export the plan as a standalone object, and the learner is pretty much an estimator, a scikit-learn estimator that takes a dictionary as input, rather than just X and Y. And since it's a dictionary, you can pass arbitrary values to it, and this is also how you can pass a URL to a remote bucket. So what you do is you do a make learner, which is fitted on the data that you have passed. Then you can pickle the learner, and then you can load it somewhere else, and then you apply it to new data by passing the new data as a dictionary where the names of the variables are, the name of the keys are the variables that we define at the very start. And then you get the actual predictions at the end. I was saying we want to hyperparameter tune everything in the pipeline, so in the plan. And you can do this with the choose functions. So you can choose from a list of options. You can choose a number within a float or an integer within a range. You can turn on or off a Boolean flag. Or you can also say, okay, I'm not sure if this particular operation is useful or not. I can mark it as optional. And during the hyperparameter search, it's going to turn on and off that option as one of the possible hyperparameters. So I don't know if this join is useful or not. Let's put it optional and see. So if you're familiar with hyperparameter tuning in scikit-learn, you know it can be a bit complex, a bit wordy. You need to remember, all the syntax, you need to write the full thing. With the data ops, it's much simpler because you are just defining them where you are defining the estimator. So in this case, I want to choose between regressor, which is ridge, or random forest. And I wanna choose for ridge the alpha, and for a random forest classifier, the number of estimators. Why is it a classifier? I'm not sure why. Now, let's ignore that slide. Gonna fix it for the next version. But the idea is that it's going to build the full hyperparameter grid for you, and you don't have to do anything. Also, the code is written there, so you don't have to find out where you defined your grid. Then you run your hyperparameter search, and you save the best learner. And this is what you can use to put in production, for example. Once again, this is not limited to estimators. You can choose from an aggregation function, for example. And this is the very scary parallel coordinate plot from before. That is, once again, animated. And I'm not going to go into much more detail now. It's just going to show that you can actually highlight which are the hyperparameters that are more important that you might want to tune in later stages. Then we're almost done, actually, because if you want more info about the data ops, you can find it in the example gallery in the main website. There is also the user guide, which I spend a lot of time on. Hope that it's helpful. There is a tutorial that we give at EuroSciPy 2025 on time series forecasting, also with Guillaume, and which is actually where I got the parallel coordinate from. So if you're curious about that, you should look at the tutorial. Then there is the very simple Kaggle notebook that I wrote just to test out the DataOps on the Titanic Survival Challenge. Almost done. So what happens if you put together the table report, the cleaner, a lot of feature engineering encoders, and a bit of chemical X in the DataOps? You get Skrub, which is the package that I've been talking about for the past 25 minutes. You can install it with pip install Skrub or just with Conda. And yeah, if you think it was interesting, you can learn more on the website. We have a Discord server where we answer questions. You can follow us on Blue Sky and on LinkedIn. And please, if you find this useful, start a Skrub on GitHub, or if you want, you can contribute directly to also tomorrow, because we actually have a sprint tomorrow. I thought it was registered. I need to register. We are hiring. If you want to come and work with me, come talk to me, or go to the P16 booth, which is close to the probable booth, I think, in that direction. And this is my final slide. I will leave it here so you are reminded of what Skrub can do. And remember that at the bottom there is the footer for the link to the slides. That's it.
Very nice. Thank you, Ricardo. Do we have any questions for him?
Thank you for your talk. Just a practical question. Dealing with a string encoder, with tabular data, we often meet column with countries.
Yeah.
And so if we have more than 40 countries, the recommendation is to use string encoder instead of one encoder for countries.
Yeah. So the idea is that if you have more than, by default is 40, but you can change that. If a column has more than 40 unique values, it's going to use the string encoder by default. But if you want, you can use one of the other methods, or you can increase this value so 200, so you don't use it, for example.
Yes.
Maybe a comment on that question, because my group did a bunch of my research group did a bunch of research on this. An easy way, so the country names don't always relate to their positions on the globe, or interesting information. So maybe here I would use the text encoder, which you could then pull a large language model from Hugging Face, which will implicitly come with world knowledge. Or you can do complicated feature engineering, of course, but that's a simple way to move forward.
Another question.
For example, let's say if I want to do one hot encoder for most frequent, let's say 10, 12, or most 15 most occurring numbers, can we do that?
Not with a built-in. You would have to. What you could do is you could write your own. Not by default. There are ways to get Skrub to do it, as in either you write your own function and you put it in the DataOps, or you write transformer and you pass that to the table vectorizer. Then it's going to dispatch. But you have to write the code for yourself.
I think the scikit-learn one-hot encoder is supporting that.
Oh.
So then that's you need to parameterize it.
Okay. Then use the look at the documentation. I didn't.
Thank you for the great talk. So I was wondering regarding the cleaner. So if I wanted to use the data for something else, like build a report or something like that, is there a way to extract the computation graph from that?
Not at the moment. So what you can find in the documentation is what are the steps that are done by the cleaner. There are some steps that there is one argument that I used here, which is off by default actually. So you can say I had to turn this flag on or off, but we don't have for the moment a way to detail all the operations that are done. We actually want to do that.
Ricardo, I have one question concerning hyperparameters. Do you enable the user adding their own hyperparameters?
Yes, so you can use arbitrary like you can put anything in the choose from. You can put your own functions in the choose from. All Skrub is going to do is going to pretty much re-execute, like explode the full hyperparameter search and rerun the operations with whatever code you write.
I actually have a question if no one else wants to ask one. So I've seen the term data ops before, but I think I had a broader perception of it. When you talk about the data ops plan, do you mean like a standard, like a format? Okay, no. But would you consider that the data ops plan that you can generate in HTML, should be like a sort of standard for sharing data analysis workflows?
That's a very interesting question, which we haven't considered in the slightest, but I guess maybe we should now.
I'm curious. I'll take a look at it. Any other question? If not, we'll thank. Oh, so excuse me. Yeah, I saw someone over there. Yeah, in the dark.
Hi, thanks for the talk. So this is very relevant for writing batch AI systems. So, your data pipelines are primarily batch, but have you considered Skrub for things like real-time AI systems and now context engineering for LLM-based systems? And is that outside the scope?
Not at the moment, yeah.
Okay.
Any other question? If not, we'll thank our speaker again. Thank you so much.